All right, let's talk about one of my favorite topics, the tiny human brains that you can grow in a literal jar if you want to. The ones behind me are Neanderthal organoids, and we will get there, but I want to talk about the medical applications first. If you've been following me, you'd know that I've been covering these guys for a long time. And yes, I will continue to bring you updates as they come, but let's get into it. Brain in a jar is no longer a philosophical question, but a reality. The first induced pluripotent stem cells were invented in 2006. An induced pluripotent stem cell is the ability to take a stem cell and then take it back to something that's more embryonic so that it can become any cell type. There's been a lot of fraud and a lot of drama in this field. Everyone has been after a better way to make stem cells that don't have limitations. As a result, much of the research in organoids have started out with somewhat differentiated stem cells. So skin cells can become neurons, and they're often used. But the best way to make a organoid is to use something that's already differentiated into that tissue. And this is why fetal brains, embryonic brains, are very good as a starter, almost like a bread starter. These guys develop essentially the same way that a human brain would in embryonic development, except they are disembodied. They can grow eyes, and they are in fact light sensitive. So if you shine light on them, they will have some brain waves. So if they had a concept of a thought, it would be there. They are, however, not considered to be conscious. They are arguably sentient. Sentience in this concept is the ability to react to stimuli. With that definition, all life is sentient. Believe me, there has been an absolute firestorm of questions about the ethics of using these guys. Brain organoids have actually been around since 2013, but it wasn't until people started putting them in robots or using them for computation that it really hit the news. Yes, one of my favorite researchers, Alison Moultrie, put them in a spider robot. These guys are tiny. They're about 10 millimeters across at the largest, although there's been a lot of research that's making them bigger. The longer that they develop, the more similar their brainwaves become to that of a fetal human. They're comparable, although they are much, much smaller. One of the greater limitations to keeping these guys alive is the starvation for oxygen, because they do not have a circulatory system. There's been a lot of really cool research into how to give them a circulatory system, and some people, like Allison, has managed to keep them alive for 10 months. The longer they're alive, the more complex their brainwaves become. The gold standard at this point for keeping them alive is to put them in the skull of another animal. And they do integrate. They do eventually have all of the brainwaves that you would expect of a human, as long as they're supplied with blood by another creature. One of the reasons these are so exciting, aside from the spooky aspects, is they have the possibility of healing brain injuries, something we've never been able to do before. There's been research in trying to heal brain injuries with just stem cells, but it's never been effective. Those stem cells do not end up differentiating into brain tissue. Often they can differentiate into something you don't want. I do think part of that is because once you introduce new stem cells, they then have to proliferate. People who have stem cell transplants for bone marrow can often get cancers as a result. At no point does your body want to make a whole shit ton of bone marrow, but you are inducing a system that wouldn't normally be there. And if you divide your cells, you can end up with cancer. It's not just stress or radiation that can induce cancer. This is why your body has strict checkpoints when it comes to your cells dividing. There is quite a lot of research on using these guys to heal damaged portions of the brain, and it started in rodents and more recently has gotten to monkeys, and it is shocking. The reason that they use human brain organoids in this kind of research is because it needs to be applicable to human medicine. If you are eventually going to move to humans, you don't want all your research to be in mice, and fortunately it takes hold pretty well. When it comes to mice and rats, they're going to use immuno-insufficient varieties, so they don't have much of an immune system anyway. But your nervous system is also an immune-privileged area of the body, which means your immune system is not going to operate in that area, and it's far less likely to be rejected. Brain organoids are essentially fetal human brains. They are baby brains, and they can still grow. They still have much more plasticity than we have in adult brains. When you pop them inside of that skull, they can make projections all the way down to the brainstem. They have no problems with communicating with mouse neurons at all. In fact, you can grow one just simply near the decapitated spine of a mouse. They did have to teach it that there were muscles to move with little electrical impulses, and then it kind of got the hang of it. We have had a lot of success with moving them into animals who have induced strokes. Researchers damage the area of the brain that controls for visual relay, and the brain organoid could go in there and differentiate into the correct kinds of tissue. It relayed information from the eyes to the rest of the brain. It restored sight in rodents. The reason that we're not moving directly to humans is because we want to make sure that we have the best methods possible before we start putting them in people, because having that go wrong could hamstring the entire industry. When we work with people, we want it to work. This is where some of the most exciting research has come out of. Researchers did put them into the skulls of monkeys, rhesus monkeys, that had induced strokes. It worked, for the most part, but they learned a lot in that process. Like, they had to wait a little bit before actually doing the implantation because otherwise the cells would not successfully take hold. They also found that you have to use mature brain organoids. They have to establish themselves a little bit before they go into that brain. I do think we're going to see human trials in the very near future. I don't know if they'll go to chimpanzees first because chimpanzees can live like 40 years. We'll see. Some other questions that people often ask: does it have its own consciousness if you implant it? Could it take over? I have no idea. Maybe? Join me next time and I'll tell you about some of the more disturbing applications, like using these guys as a method of computation and selling them as a subscription to the public. That is developing, by the way, because there's been an international effort to learn how to use them and use them better. And the really cool activity of creating Neanderthals in piecemeal, rather than just cloning one, which we probably could do, is we just made their brains.